Alright, so now we are on 5.3 with Laws of Logarithms. So, you know what to say. When in Rome is the best band ever.
You'll find Ken wherever toys are sold.
Laws of logs. So, what happens here with this log? If you have log base A of two numbers inside, whether it's multiplication, you can actually separate those with addition. You can take the log of base A with the first thing and log of base A with the second. When you have division inside with logs, that, if this is multiplication, and that means that you can add them, when you have division inside of there, you can actually subtract the top from the bottom. Log with a base something of A and a number with an exponent there, you can actually take that exponent and put it on the outside. That's what you can do with that log there. So example 1, I know it looks crazy, okay, but it's about doing this stuff step by step. So division with logs in multiplication, right? So I have a division sign here. So that means I have to take whatever's on top and subtract it from whatever's in the bottom. So that's what I did. All that's on top, right there. All of that's on the bottom. So minus that. Okay. Next up is, I'm looking at this, seeing multiplication. If you remember, multiplication with logs. Okay, if you remember multiplication with logs, that's saying, hey, addition. So I pulled that apart and put an addition sign in between there. So I pulled all three of these apart. Now, the square root is actually, I know you might have a hard time seeing this, but remember, the square root's like saying y to the half power. So I got to make them all exponents. So now that's an exponent. That was an exponent already, and so is that. So now we have to remember the third law. The third law says you can take the exponents and move them out to the front. So I'm going to take that 3 and move it out to the front. I'm going to take that half, move it out to the front, and take that 2 and move it out to the front. So your final answer would be 3 log ax plus 1/2 log ay minus 2 log az. That's your final answer.
The only good cat is a stir-fried cat.
Example 2. Okay, we want to combine that as one. So now we're doing everything in reverse. First, take all the numbers out in front and move them to the exponents. So this is a number out in front, I got to move that up top. This is a number out in front, I got to move that back and make them exponents again. So that's the first move, and there you go. So I moved that, made it to the 1/3 power, and moved that 4 and made that right there. So minus signs just mean division all over the place is what it means. So now we have too many subtraction signs, right? Minus, minus. If we do everything in order, we'll end up getting a fraction over a fraction, which just doesn't look nice. So thus, we're going to try to factor out a negative is what I'm going to do to make this look a little nicer. So here's what I'm doing. I got all this, right? Okay, minus. I took a negative out of those two. I'm going to take that subtraction sign out. So minus, when I do that, I end up having an addition sign now in between here. The reason why I do that is because this is going to make it much easier to get the final answer. Because when you have a whole bunch of negatives in a row, you're going to end up having that divided by that, divided by that, divided by that, which is just going to make things really hard to solve. But now you have addition. And the opposite of addition is multiplication when you're talking about logs. So you can now actually smush those two together to make one item. So now it's log A y z the fourth. And there's only one subtraction sign now. And if you remember from subtraction signs, the opposite in logs is division.
Did you ever look at a dollar bill?
So now that subtraction sign turns into division. So with one log on the outside, I have all that on top divided by all of that. And that 1/3 I can rewrite as the cubed root. So your final answer is the cubed root of x squared minus 1 over y z the fourth. So there's all that smushed together. Example 3. So taking a look at this and trying to solve, I see that k, that's like a number out in front, so I can move that up to the top of p. Okay. Then I see a subtraction sign, so that's like saying division, so I could do log of a, log base a, so it would be c divided by pk when I smush it together. So really, since they now have the same log and the same base on both sides, I can just do d equals c over pk to try to solve. So 1/2 of log base 236 minus log base 23. Well, once again, I have that. If I want to smush these together, I got to get rid of that to condense it. So I'm going to move that 1/2 up to the inside. So I get 36 to the 1/2, which is really like saying, hey, what's the square root of 36? The square root of 36 is 6. So really now I'm saying log base 2, 6 minus log base 2, 3. Well, since it's subtraction, that's like saying, hey, do division. Well, what is 6 divided by 3? 6 divided by 3 is 2. So really I'm saying log base 2, 2. And if you remember from those properties from the last section, when they're the same, they cross out and it makes 1. That is your final answer. Taking a look at this problem here, there is no numbers out there, so I can just smush those two together and make it a times b. And then this 5 I can put out to the top. And so that's what I did there, put it out to the top. And now it's subtraction, so it's like division. So I can do c over ab to the 5th. If I wanted to, I could take that little 5 through to both items. So now to expand these, because those are some example problems there, we're going to come back and we will expand some problems then.